Welcome to the YouTube channel Command Line. In this video, we are going to learn about logarithm or log. So we are going to enter into divide and conquer section. Before entering into the divide and conquer section, it's better to know what is log and what is log operation means and how to calculate log. Because when you are going to analyze the divide and conquer algorithms, log will come into picture, because if you don't know what is the basics of log, then that will be a little bit of struggle. Moreover, if you already know what is log and how to calculate log, you can skip this video and go to the next video in the playlist. Let's start with basic mathematical operations. We have known elementary mathematical operations like addition, subtraction, multiplication and division. So these operations are applicable to two operands. Let's say you take the addition in the first bullet pointer. It is applicable to 2 and 3. So the answer is 5. So it means any mathematical operation means we are going to do some operation on one number or more than one number. So there are some complex mathematical operations like power. So we have 5 power 2 is 25. So there are again two operands. 5 is the base and 2 is the power. And another complex mathematical operation is factorial. So here we have only one operand, 3 factorial. 3 factorial is 3 into 2 into 1, which is 6. So we have basic mathematical operation like addition, multiplication, division, subtraction and modular division. Also there are complex mathematical operations. Similarly, do we have any operation for dividing? Dividing in the sense we are not going to divide like a division. Let's say I have 16 footballs. Now I want to divide that into 2. I want to divide that into 2 sets. I will keep dividing until I have just only one ball in one set. So I want to know how many times I am going to divide that. I want to know how many times I can divide 16 into 2 until I reach one set, like I cannot able to divide that further. Okay, let's take this 16 as a football as an example. So first time I am dividing into 2. Each set will be having 8 balls each. So this is first time I am dividing, 16 become 8 and 8, 2 sets. Then I am dividing both sets into 2. It become 4, 4, 4 and there are 4 sets. Then I am dividing each 4 set into 2. So now each set is having 2 footballs. I have divided 3 times. Now I have total of 8 sets and each set is having 2 balls. Now I divide one more time, because each set is having 2 balls, I can still divide into 2. Now I have total 16 sets. Each set is having just only one ball and I cannot divide further. I want to know, like, now you can see I have divided 16 into 4 times until I reach there is just only one element in a set. So now the question is, I want to know how many times I can divide 16 into 2. How many times I can divide 16 into 2 until I reach just one in one set. So the answer is 4. When you divide 16 into 2 sets for 4 times, I will have just only one element in a set. Now do I have any mathematical operation for this? Yes. That is log. So you can write something like log of 16 is the number, the initial number which I am going to divide, and then how many times I am going to divide in each step. I am going to divide into 2 sets in each step. So that comes under the base. Now the answer will tell me how many times I can divide 16 into 2 sets. Like I can divide 16 into 2 sets for 4 times until I cannot further divide. So this is log. So log is nothing but you have some initial number and you are going to divide that into some number of set. Like you have m element in a set and you are going to divide that into n times in every step. Now log will tell you how many times you can divide that until you cannot divide further. Further elaborate here. So let's say I want to divide 27 into 3 sets and I want to know how many times I can keep dividing. So first time when I divide 27, like it becomes 9 in each set. I have 3 sets and each set will be having 9 elements. And further I divide all the 3 sets into 3. I'll have 9 sets of 3 elements each. Then I divide everything into 3. Now I will have like 1 element in a set. So how many times I have divided 27 until I reach 1? 3 times. Then this can be written as log 27 base 3. So it is giving me the answer 3 because I can divide that into 3 times. Now similarly you take log 625 base 5. It means I am going to divide 625 into 5 sets until I reach just one element in a set. So 625 first divided 125 element in a set. Next time it will be like 25 element in a set, and third time it will be like 5 element in a set, and at last the last step like 1 element in a set. I have divided 625 into 4 times in 4 steps until I reach 1 element in a set. You take same for 256 base 4. So 256 divided into 4 sets, 64 divided into 4 sets, 16 divided into 4 sets, 4 divided into 4 sets, 1. We have done 4 steps of dividing 256 into 4 sets, and so that the log 256 base 4 is giving us 4. So by this time you should have got some idea what is log or logarithm. So we have two elements, two operands in the log operation. One is actual number, another one is the base. So now the log means how many times we can divide the given number into the base sets until we cannot further divide. And if you look clearly, there is one interesting factor here. Log is it is the inverse of power. Let's say log 27 base 3 is 3. Like we know log 27 base 3 is 3 because if you divide 27 into 3 sets, you can do 3 times until you reach 1 in a set. So 27 can be written as 3 power 3, right? So now you write the same thing as log 3 power 3 base 3 equal to 3. So it means when the given number is a power of some number and the base, both given number and the base is same, the power will become the answer. Same is applicable for log 625 base 5. 625 can be written as 5 power 4. So same when log 5 power 4 base 5 is answer is 4. Same goes for 256 base 4. 256 can be written as 4 power 4. So log 4 power 4 base 4 equal to 4. So you should have got the idea, like log is the inverse of power. And one more phenomena here is when there is no basis mentioned in a log, it means implicitly there is 2 in the base. When we say like log n base 2, we mostly won't mention the 2 there. So it will be simply mentioned as log n. For example, when I say just log 10, it means it is log 10 base 2. This we have to remember. Here is an interesting phenomena. When we analyze algorithms, we want to know what is order of growth. Okay, we know the order of growth for n, we know the order of growth for n square, we know order of growth n cube and n factorial and all. So what will be the order of growth for log n? Because when an algorithm is performing in log n level or n log n level, we should know what will be the order of growth so that we can decide whether to take the log n based algorithm or some other algorithm. Let's see, like if it is log 2, I have already told you if there is no base, it means there is a 2 in the base. So log 2, the answer is 1. And then log 4, the answer is 2. And log 8, the answer is 3. So you can see if the log 2 answer is 1 and log 4 answer is 2, that the answer is growing in the ascending order. It means any number between 2 and 3 will not have a log value of more than 2. So the log 3 will be having some value between 1 and 2, somewhere around 1.7 or 1.8 in that range. So the same applicable for log the numbers 4 and 8. Any number between 4 and 8, 5, 6, 7 will not have the log value more than 3. So all the number will be having log value of 2 point something until it reaches 8. When it goes to 8, the value becomes 3. So same goes for log 16. Log 16 is 4. It means any number between 8 and 16, like 9 to 15, will have log value of 3 point something. And then log 32, which is 5. So all the 16 numbers between 16 and 32 will have the log value between 4 and 5. So then log 64, log 6. So 32 numbers between 32 and 64 falling in 5 and 6, between 5 and 6. And 64 to 128. All the 64 numbers between 128 and 64, the log value will be falling between 6 and 7. So if you see here, initially the log value is growing little bit higher, but when the n value is like the x-axis grows further, the y-axis growth is very small. Like for the 64 numbers between 64 and 128 is just 1. And 128 numbers between 128 and 256 is just 1. So the difference, the y value grows very slowly. So let's see the same thing in the graph. White color line is O of n, which is the linear growth, and the yellow color line is O of log n base 2, which is nothing but log n. So you can see the growth, right? Initially the white line and the yellow line are kind of same, they are starting together because the log growth is also a little bit linear, but over a period that growth has tapered down and the growth is like very kind of slanting. So this is what the betterment here. When we write an algorithm, when we measure the algorithm's performance based on the input length is nothing but n here, When the algorithm's growth is order of n, the algorithm will grow linearly. As the n grows, the running time also will grow equally. But if you see the log n, when the algorithm's performance is log n, you can see as the n grows, running time is not growing that far. So when the n becomes very big, the running time is not going that big. So the difference between big O of n and big O of log n, it becomes like huge. So obviously an algorithm which order of growth is log n is definitely better than an algorithm whose growth is O of n. So we have reached the end of the video. Here is the summary. Whatever we have learnt is log is nothing but it is one more mathematical operation. It is little complex like power or factorial. It is still another mathematical operation which is going to be applicable for two operands. And second is log is nothing but how many times I can divide a given number into another given number set, into the base number of sets. Let's say if I have like 16 number and the base is 2, I want to know how many times I can divide 16 into 2 sets until I cannot divide it further. And we have learnt log is nothing but it is inverse of power. When you know 5 power 4 is 625, so if we put log base 5 of 5 power 4, the answer is 4. And then we have learnt the order of growth of log n. So any algorithm whose order of growth is log n, it is obviously better than algorithm which is growth is order of n, because the growth of log n is slower than growth of n, the linear growth. The log n growth is slower than the linear growth. Hope this video was useful to you. You learned something new. Please comment if you have any more queries about this particular topic, and please tell me in the comment if I have to change anything in the video or I have to make something better here, or I'm going very fast or very slow. Please let me know in the comments, and thank you for watching.